Państwu. Good afternoon, everybody. Thank you for coming. Thank you for our dean organizing this meeting, this seminar. We have today two special things. One thing is just a few hours ago, we got a new satellite, biomass satellite, just launched on orbit. The name of the satellite is biomass. So many of you are working with biomass, so it's pretty interesting to have first time on orbit European product using P-band sensor, so rather a microwave sensor to check, to measure the biomass of forests around the whole world. And second thing, today, also important, is a visit of Professor Liou from NCU University in Taiwan, city Taoyuan. It's not easy to pronounce for me. So we started our collaboration many years ago. This was 2019, I think, when I was visiting with our colleagues from Italy for his invitation, the laboratory, the group of space research and remote sensing research at his university. And today we have opportunity to meet him and his former PhD student, Kim An Nguyen from Vietnam. She's working now in the Vietnam Science Academy. And Professor find time to give a speech today. He achieved his PhD in US. It was in year 1996, I think. Yes. He was in Michigan, University of Michigan, US. He got double degree. And he's author of more than 100, so we put 100 because I got not updated information from you, but he published, just last year he published 20 publications with his big team of PhDs, like 20, right? So he will introduce later himself. So he's a specialist of remote sensing on using very modern sensors and calculations of indicators about environment and risk and hazards of environment, what's happened today because of climate change. So you will get overview how to use remote sensing, how to use special algorithms and machine learning maybe and other solutions to observe and monitor our world, what's happening, how the world is changing. I think it's all from my side, so the floor is yours. Okay. You have, let's say, 1 hour. You will get a microphone from me, and you can start. If you will get some troubles, you can help you. No, perfect. Okay.
So thanks to Peter for inviting me here to give the presentation. I think that they can hear well, right?
No, because we are broadcasting now. It's on? It's muted. Okay. Now we are on.
I see.
Well, even in Taiwan, they can hear it.
Very good. Thank you to Peter for inviting me here to give the speech. I am Liou, Chinese name or Mandarin name is Liu. I am from National Central University, the Center for Space and Remote Sensing Research. Initially, my presentation will be based on this one, more academic. But 2 days ago, Peter said to me, why don't I introduce our university center to the audience? So I would also introduce our center with a hyperlink. I would explain a little bit about our center, our university to you. And in this presentation, I would focus on roughly 2 or 3 fields focus of my research team is doing now. And through the QR code, you can find my publications. And this is logo of National Central University, our Center for Space and Remote Sensing Research. And this is the logo of my lab. And this is today's title. I taught my students to think innovative. When we work on research, we pursue innovation so that our outcomes can become important and meaningful, valuable to the society. So in the past few years, we developed some new indices. The students just follow my work and think hard to create new things. And I think one of the important things is the new satellite indices, or indices that we develop helpful for remote sensing. And I think this index is very useful for the community. And I will introduce them to you. And one important topic that I like very much is about equal environmental variability assessment or risk assessment. This will be another major topic to be presented today. And this is the antenna on top of our building. Our center was established 40 years ago, more precisely 41 years ago, 1985. And this antenna, you can see this is me. I'm here. So this is the antenna, is a 30 meter antenna. And it's installed on top of the building. So its function started 30-some years ago until now. When it moves, we feel the building is shaking. So we have been working in that environment for a long time, and the building is still there, so it's quite safe. No problem with that. And so this is about it's a 5-story building, and this antenna was stored on top of the building, and it's a major receiving station in Asia. It was started quite early, so the stations, satellite receiving stations, the people who intended to start receiving station came to our center to learn how it operates, how it's established. So this shows my academic experience. I started with the electrical engineering. Initially, I thought of pursuing graduate studies in optics. My former professors are very good in optical engineering, so I thought that it could be a nice field for me to work for my academic or my future. So after I got a bachelor's degree from Taiwan, I went to University of Michigan. I joined the electrical engineering and computer science department and got a first master. And then the group in the university, they do research in remote sensing, and there's a lot of faculty members work on remote sensing. Later, I got my second master degree in atmospheric oceanic and space science department, with major in atmospheric science, minor in space science. Then I got a double PhD degree from University of Michigan. I think it's important for the students to learn more. It will be helpful for you to develop in the future. I believe I benefit from my training at University of Michigan. So after my graduation, I was able to understand the different language from different fields. That it's important to communicate with the community. And this is my academic background. I started to serve as Space Agency of Taiwan, National Space Program Office, and now it's called the TASA. It's in charge of Taiwan space programs. I was the division director of science research development, and then I served as a dean and then the center director in this time frame, and then I was the founding president of Taiwan's group on Earth observation. And then I was invited to appoint as the president of Taiwan GIS Center under National Development Council that is in charge of primary national projects. This just sent as a lesson. And this shows the next 2 pages. I would just briefly show you the international cooperation project that I participate in the past. In recent years, I was a PI for the project sponsored by Taiwan's most Ministry of Science and Technology. Now it's renamed as National Science and Technology Council. This is Life Environment. It's a project supported by Life Environment of a program in EU, and that is a project that I get to know Peter. And also in the Copernicus project and others. This is citizen participation project. And also earlier, I was involved in FP7 project. This is about essential climate variables, ECV. So I had some experience in the EU participation in the EU project, and I'm hoping that in the future we can develop cooperation between Taiwan and here. And this is my first time to come to Poland, although I have been to many countries in Europe, but this is my first time to come to Poland. And this is my team member. In year 2020, I do not have the update of team, but it's just to echo Peter's suggestion to introduce my team. This is the lobby of our center, and you can see that there is a dish on top of the building. So it's like a 1, 2, 3, 4, 5 on top of 5-story building. And this is NCU logo. It's a quite beautiful campus. You are welcome to come to Taiwan if any chance. And I hope to welcome Peter in July this year. So I'm back to the academic portion of today's presentation. It will consist of three parts. The first one is about innovative indices we develop, and I will explain to you the meaning of these indices. And the second one is about urban heat island. It's a study of Taiwan's urban heat island. And then the third portion is about eco-environmental variability assessment. We conducted that work before COVID-19. And during COVID-19, you know, the environment, the Earth environment became much better. So we did that work and see the difference, a big difference. The Earth became much greener. So I would present the three portions in this part. Now, Peter just said that I had 20 papers, journal paper last year. I did not pursue a lot of journal papers. 20 papers to us is a lot. So 20 is the maximum number my research team produced in a year. That's a quite huge number. And before that, of course, my paper number is not so huge in a year. And part of the reason, certainly because my research group is big and 6 PhD students graduated in the past 2 years. That's why I had more papers. And my research outcomes are considered to be helpful in 9 SDG, Sustainable Development Goals. So it's wide spectrum. The areas covered by my research team are considered quite broad. So here, briefly introduce why we conduct a research and the indexes we develop, and then share with you the urban heat islands we study about the Taiwan's UHI and global environmental variability, and then conclusion. This shows the temperature increase for the past 100 years, 1,000 years, and 10,000 years. I think, I believe all of you know that the Earth becomes warmer with time. And this time frame, actually, the discovery of the global warming, about this time frame, the scientists discovered that there's a trend, this trend. And then over this time frame, in the past few decades, it's been recognized global warming exists. Although now, Trump said that he doesn't believe global warming, but we still believe that it happened. And nowadays, we experience more extremes, different kinds of extremes. So we human beings have to work together to face the challenges brought to us due to the global warming. So we experienced a different type of extreme forest fire. You see like America, South Korea, and enhanced cyclones. In our region, we experience cyclones a few times a year, and right now, in recent years, the number of cyclones is not increased, but the number of intensified cyclones is increased. That is a problem, because intensified typhoons will bring more damage to the society. So we experience different kinds of extremes, forest fire, cyclones, flooding, and to Taiwan, we count on cyclones to bring us fresh water. About 60 to 70% of fresh water comes from cyclone. So without the cyclone, and in a year, and in the next year, without monsoon rainfall, we experience drought. So my research team studied cyclone and also drought. And it becomes a big story when Taiwan experienced drought. As shortage of water, fresh water, would impact the industry, such as semiconductor industry. You may know that Taiwan is famous for production of semiconductor chips, like TSMC, Taiwan Semiconductor Manufacturer Company. that company produce the high-end chips to supply to the whole world. And more than 70% of high-end chips are produced in Taiwan. But that company consumes a huge number of fresh water. So shortage of fresh water will become a serious problem to Taiwan. So we are facing different types of environmental issues. And we, as research group working on remote sensing, we utilize remote sensing as a tool, and also the like AI, the new technology, to help us resolve the problems for research. So we count on that. So now I'm going to introduce you the environmental, actually satellite indices we developed. NDLI, TMDI, SWATI. They are based on the reflectance of different satellite bands, reflectance. These indexes will be useful for land surface, and I think also for green space, greenery regions studies. So this shows the NDLI. It's a normalized latent heat, normalized difference latent heat index. I believe most of you, or maybe all of you, know NDVI, normalized difference vegetation index. NDVI is defined as the ratio of green band and the red band reflectance versus the sum of band. And NDLI incorporates additional bands reflectance at short wave infrared, so that this new index is not only sensitive to the greenness level of the land, but also the surface water availability. And these indices are presented in IEEE transitions on geoscience and remote sensing. So I show you some figures published in that paper. More information can be found from the papers. You know, during the presentation of the new index, we would need to compare the results of the new index with the existing indices to show that the proposed new index is not only working, but also performs better than the existing indices. So for the surface moisture and evapotranspiration variability study, we compare the NDLI with, like here, this index, NDWI, different version of NDW and NDVI, and to see how the new index perform as compared to the existing indices. And this shows the different pattern what you may see probably here, like a water built up agriculture and vegetation. So this is in this region of Taiwan. And we use this region. This will be more agricultural region in Taiwan for our series study. This shows in more details the comparison between NDLI and other indexes. NDLI, this shows correlation of latent heat flux and water index. So the others, we call them water index, we use them to derive evapotranspiration. And you see that this is NDLI, and there's a correlation. So for different land use, the whole area, study area, and the water, agriculture, vegetation, and the build up. So you see that this, it outperform than the other indexes. Well, this is what we are supposed to show, that the development of a new index performs better than the existing indices. And this side is a scatter plot of the NDLI versus daily surface temperature. You see the equation 0.7. And from the map, you see that NDLI, NDVI, and the other two. You see the big difference. And the difference would tell us how good or how much better the new index would perform. So having the development of the NDLI, here it shows another version, TMDI, surface moisture for temperature, as for the detection of surface moisture and evapotranspiration variability. And the TMDI is defined as this way, primarily on the temperature, daily surface temperature, difference between daily surface temperature and daily surface temperature. This is minima and this maximum minima. And the ST minima and the maxima are defined this way. So you see, NDLI is in. So we utilize the information that can provide us from NDLI into the TMDI, and so the value of the index will be revealed from the use of from this equation. And you see, this shows the correlation between TMDI, TBDI, and the SABLE derived EDs. SABLE is a model commonly used to derive evapotranspiration. And you see that for different type of land cover, this is correlation. There's a ET and a TBDI, TMDI. TMDI, the correlations appear better than the other. So we showed the advantage of TMDI. In the earlier, we showed that for NDLI, and this for TMDI. This is another case showing the TMDI's advantage over another index developed earlier. So the index we propose performs better than the other index presented earlier. And for this is Taiwan's the main area to produce agricultural products, the southwest of Taiwan. It's called Yunjiang, three counties in Taiwan. And since TMDI is sensitive to the surface water variability or evapotranspiration, on the other hand, it is sensitive to the dryness. So for drought assessment in this page, in different years from 2014 to 2021, 2014 to 2021. And this is the year that we have a drier situation. Generally speaking, Taiwan has a lot of rainfall. However, if we do not have a cyclone to come, and in the next spring, the monsoon doesn't bring us sufficient water, we would encounter a shortage of water, fresh water. And this is with time, and then different region from north to south, and the different color shows the dryness level. Okay, so this is a newer index. It's more complicated. It utilizes NDLI, and NDVI and temperature. From this equation, you see NDLI, the index we developed, and NDVI counting on the brightness, and this is surface temperature. And this is the equation that we propose. So it is a function of brightness level of the land, and also surface water availability and the temperature. These are the fundamental parameters that we rely on to determine the land surface wetness, dryness, temperature. So you see that Swati would be able to provide us the information of this. And then we use that to study the global drought status. Okay? This is also presented in attribute relation on geoscience reprocessing. Then we can show the global drought scenarios. I have other two topics, so I show you and allow you to take a look. If you are interested, we can talk about this in more details. Next, I will move into the surface urban heat island. This is also a drought. I think you will know that the urban heat island effect, we see that the temperature difference between urban and rural areas. And for diurnal, seasonal, and annual, the urban heat island. For this study, we utilize 11 cities from north to south of Taiwan, very detailed, and utilize maybe 18 years data time frame. We analyze data from for this time frame, 2003 to 2020. So, urban year with it. It's good to know that there's a well-known consequence of urbanization phenomena that urban area experience higher temperature than the surrounding areas. So this study, the objective to investigate the diurnal, seasonal, and the spatial patterns of the surface urban heat island intensity in 11 cities in Taiwan, from north to south, and identify their possible driving factors. So we consider 8 factors. It's a little bit complicated. We utilize this is a research for a chart showing how the satellite data are used and the methodology and classify land use and cover, etc. And then we not only use the satellite data but also use the workstations data. And then this is central view like a back office in some countries, back office. And we use this data to derive the urban heat island intensity and then in the end compare the results to see the diagonal variation, seasonal variation, and spatial distribution, etc. Abbreviations, definitions are given here. So this is easier to see and to understand. You see the 11 cities from north to south, the Taipei, Taoyuan, to Kaohsiung City. And for nighttime, daytime, nighttime difference, and for summer, winter, the difference, and for the difference between them, so to get the day-night difference. And this shows the comparison. Daytime, the intensity of the urban heat island, and at the nighttime is a big difference between daytime and nighttime. And for the northern, this part is for northern, this part is for southern. From the earlier slide, you see the urban heat island intensity appears stronger in the north than the south. So in the north, stronger than the south. In the north than the south. So more, this shows the seasonal variation. So the results, each slide is very busy, quite informative. So, and a lot of number. Here we also use the NDLI for comparison as compared to, here's NDLI, EBI, and other factor. You see that the NDLI shows us good correlation. So NDLI, we believe, due to its additional information of surface water availability, is not only useful for temperature, thermal signature study. I believe it will be also helpful for greenery studies, like the forest. So try to use it for forest study. Let's see how it will be helpful to your work. So I will move to this conclusion will briefly describe the slides. Jump to the next one. Eco-environmental vulnerability assessment. This part I'm also interested very much, especially from we conducted before COVID-19. We see very nice global eco-environmental vulnerability map from the study. And during COVID-19, essentially the humans do not move, just stay home. No transportation, no airlines. And then the earth becomes greener. So certainly we will see greener earth. And so this will be a study to show us the earth become greener during COVID-19. And this shows the difference between two studies. So it's like the results of two main studies. And we see, this is a kind of summary of the results of two papers or two studies. We see the difference between two global maps. And here we see different levels of vulnerability. Very low, low, medium, medium, high, high, very high. You see that during COVID-19, before COVID, the distribution like this. different levels of variability. The whole globe look like this, from very low, medium, high, to very high. And during COVID-19, see, most regions become very low. Very low means very green, very nice environment. So this is kind of summary. So if humans just stay home and don't do anything, the earth becomes greener. And this is how we did it. We consider the important factors that influence the environment. We utilized 16 variables as shown here. From top, soil moisture, precipitation temperature, distance from a hydrological network, and etc. These 16 variables are distributed in 5 dimensions: hydrometeorology, socioeconomics, land resource, natural hazards, topography. So even like each dimension, it has like 4 differential factor, and this one 3, this 2, and this 4 and 3. Having then here and given the weights, we are able to decide, like here, the drop, natural hazards, drop, tropical cyclone, landslide, drought, okay, and the score of this one, or the weight. For each dimension, it has different weights. And for the study in Poland, you may not have a cyclone, but you have other natural hazards. You can consider other type of hazards for this type of work. So from 16 variables in within 5 dimensions, we derive the global eco-variability map. So from here, we know that we have 1 layer, 5 layers, and the 16. So in total, we have 22 shown. As shown here, we have 22 global maps. Okay, and on the left-hand side, it shows how we verify the results. So this is a map of the global eco-variability map. As you may can realize, the environment is not so good in this region, right? And then, so this is before COVID-19. Well, you know, when before COVID-19, I went to China, give speech there. They wonder why it's so red, but you may imagine why. Some years ago, the satellite that measured air pollution oversaturated because the air was so dirty. And Chinese government realized that, and then they tried to do something to improve the air quality. I think they have done something. And this is actually during COVID-19. So from these two you can see the big difference. Before COVID-19, during COVID-19, the whole earth becomes much greener. So this is quite interesting work. And this has been shown earlier, the difference between two. And this is how we verify. We utilize 16 inferential variables to determine the global map. And none of them is about air quality. And this one, we select 100 points globally about the PM 2.5, the level of PM 2.5, and found the correlation between the pollution, polluted level and environmental vulnerability. And see the correlation between them is 82%. So when our work was, before it was accepted, actually the reviewers were very curious how we verify the result. And this validation work was kind of requested by the reviewers. We utilize air pollution to verify. And air pollution is nothing to do with the 16 variables that we use to derive the vulnerability map. So having 80% correlation is considered high. And then the paper accepted. Okay, so research findings, I think I have mentioned this earlier. And now we utilize AI, machine learning, for some work that are not presented here today. But I think I may stop here and receive questions from you. Okay? Thank you.
Thank you. So I suppose this is a time for questions for the public. So we're starting discussion now. Just warming up. You mentioned AI, right? How far the Taiwanese researchers are now with using utilization of AI in daily work? Like not only making remote sensing analysis, but also, I know, make some research or query in the publications, reviews, and writing papers and so on. Or how the students are utilizing this AI.
AI, I find is very helpful. I serve as a member of journals, editorial members, and sometimes we discuss if AI, the use of AI is allowed. I support. You know, in the past we count on, now some count on the service, commercial service. We pay money to the company where native English speakers can help edit the writing.
We know this also.
But I think we do not count on AI to provide us innovative results. Innovative results should be based on our work. And the AI should be used to polish the writing, not to innovating contents. So I personally support the use of AI to improve the writing. And by doing so, certainly it will be much helpful for the student to write and easier for the professors as well. It's a lot of work to help the students writing. You may know that if the students are not writing well, and it's a lot of work, we first have to guess what is written. After we understand what is written, we can help editing. So personally, I support the use of AI tool to improve writing. And this is only for editing, but for research, we use AI algorithms to image processing. Some algorithms, different algorithms perform differently, and how good they perform. For example, like they use encoding classification. The ability of a different algorithm is different. So we can study which one will help us produce better than use the color classification method. And also having the strength of AI algorithm, it can also help us like the forecast, the scenarios, the AI algorithms will be helpful to some extent to help us like a forecast. This is also quite good. So I think now AI has been used, or machine learning has been used very widely in different areas. It has some reason behind.
Okay, thank you. So you still believe in the human brain?
Certainly, I believe you are smarter than the AI.
Okay, that's a good message. Good message. So please, ask the question. So we have questions from Astrid.
Ja mogę po polsku zadać pytanie?
Możesz.
Jak pan profesor zapatruje się na strony, które posiadają na ofercie swoje takie modele predykcyjne na najbliższe lata, jak on widzi
Klimatu?
Ocieplenia się w ogóle klimatu i zmian klimatycznych, jak on, na ile uważa, że są dobre i na ile możemy im ufać według pana profesora?
So the question is about, do you believe in the models that are already published and there are some scenarios about climate change, what we can expect in the next 20, 50 or 100 years? Do you believe on this, on how we can check it, how we can verify this? It's a political issue, it's a science issue.
That's a good question. I think it's important for the young people to think if we should believe that or not. That's a good question. It's a challenge to predict the future, like 20 years, like climate change, if it is so correct. So you see what the results the scenarios is not produced by one model. It's an ensemble average of many models. Because each model may not perform correctly. When we talk about the scenarios. So that it's quite often that we utilize the average, but we don't rely on the result of one individual model. For the future prediction, the models have to consider a lot of factors, variables. So it's not so easy to say which one is most reliable. So the temperature rising with time, we will see it's like a band. It's not a line. And that is uncertainty. So we believe in the trend and how each individual model can perform, how well it could be. I think that at least what we see, the scenarios we generally use are based on the average of many models. And the average of the many models will give us the trend that is closer to the real scenario. Do I answer your question?
So it seems to be serious problem.
It's a big issue. It's like a weather forecast. Now you don't have a cyclone here, right?
No. Not yet.
Not yet. Okay. Maybe one day you would have cyclone. We have cyclones every year, and how the cyclone would come 1 week earlier since the formation of the cyclone. 1 week, 10 days, 2 weeks, we started to forecast the track. And the track will be like this. The closer to the point where it is formed will be a 4 point. From that point, the further, the wider the possible track. Understand? And Taiwan is like 400 kilometers from north to south. And from several kilometers away, the forecast of the track from the initial point to reach Taiwan, that's like 2,000 kilometers. So when it's reached to Taiwan, it happened. If the initial guess is that it will hit Taiwan, but when it reached here, it may not hit Taiwan. Because what we get, and not what we get, the models tell us will be like something like that. Because it's a probability of the track, not the exact track, but the probability. And the probability is a range. The further away from the initial point, the larger the band, the larger the uncertainty. So it will be like the scenario prediction. Okay, thanks.
Next question. So that means if you would like to make a very precise prediction, you need to run the model very often. So you need to supply data maybe every few hours.
Certainly for monitoring, that would be more reliable. So the use of reliable monitoring system like a satellite, that would be very helpful to verify.
Every 15 minutes,
Yeah.
a forecast or something like that.
So it's very important to work on remote sensing.
So I have a question regarding urban heat islands. When we calculate the urban heat island intensity, we compare the temperature inside urban areas with some kind of a baseline outside of the urban area without the influence of the urban area. And my question is how to choose this baseline area. Can it be an area, let's say 50 kilometers away of the city in some kind of a cropland? Should it be forestland, or can it be, for example, a large forest area inside the city? Because there's some kind of discussion regarding what we can use as a baseline.
A reference.
Yeah, I think the study of this kind would have the most fundamental way. Okay, we have urban, rural area. That would be most easy pair of comparison. But now, actually, you are speaking of a more detailed, the inference of more detailed that urban heat island occur. What we need to pay attention. So a few years ago, we had a study about urban heat island, not in Taiwan, but in Hanoi, Vietnam. For that study, we at least one of the purposes of the work was to study the cooling effect or heating effect of the lake on the surrounding. Certainly, the lake, the size has to be big to some extent, so it has influence on its surrounding area. So I think that will be necessary to consider in more detail the land use they cover. And for that one, we specifically focus on the inference of the lake with size larger than half acre, if I remember correctly. And with distance, the cooling effect will be reduced. So that is a cooling area, like a lake, also urban, the greenery, like a park. It could also have a cooling effect on the surrounding, but the size of the greenery space should be big enough. If it's just only a couple of trees, then it may not have influence. If it's many, it consists of many trees, then it would have more influence to reduce the temperature of the surrounding area. So it depends. The best would be depend on what type of issues you concern, and certainly it's needed to understand the overall circumstance, so that the result derived from the work would become more reliable and meaningful.
Thank you.
I think the question was more oriented on what is urban, what is suburban, what is rural area, because the urban height island is just difference between city and, let's say, rural area. But today, the rural areas are overgrown by suburban areas. So there are many people just went from city, go out from city, they construct more houses out of the border of the city. So you never know where the city ending. So the question was maybe how far you should start to establish a reference to have a ruler, how far from the city you measure the urban height, island.
I think it would be a subjective way, to define it, but it has to be well explained, well defined, so that the readers are well informed how it is defined, and how it's defined may influence the results. Right. So I think we have to inform the readers well how the term is defined. That would be necessary. As for, I'm not sure if there's a standard way. But at least we have to define it well, so that the readers or the people who are interested in that are well informed how we do it. That would be important.
Okay. Do we have some other questions?
Yes, I wanted to ask about the global environmental vulnerability. How do you think usually predictors were most likely affected due to lower human activity during the COVID pandemic? Like the lower human activity decided that the map was bigger, but which of the predictors do you think were most determined by it?
I was wondering if you show the map of the before and after COVID. And he's asking for which why the map was not, which factors influence the most important factor.
Human factors, overall speaking. So, but then the human factors, for the weight that we utilize will be the main factors. Well, you see, in 5 dimensions, we utilize that. And which one plays a more significant role certainly is the factor that has higher weight. Okay, and the weights are very well, they are numbered. So the precisely how each inferential factor has impact on the result is very well defined based on the known weights. And given the exact number of the weights, we utilize 16 inferential factors under 5 dimensions. So these are well given. But I think this page or this page? This page. Yeah, so so exactly, actually this question can be a question for the pre-pandemic study, because you know when we intend to publish the paper before COVID-19 or pandemic, we were asked how we determine the weights. The best answer, well, at least one way to answer your question would be how the weight was determined. That's a question as well. And here it shows that the weights. So which one would be most important to bring us the green earth during pandemic? We utilize the same inferential factors, same weights for 2 studies. So this was the best line that we can compare to. And the weights are given in. As for which one would be the most inferential one, then from here we can say like, for example, like a population, that is socioeconomic. From the dimension, we see that natural hazard would be the most important inferential factor. And then for that one, we have an equal weight for 4 types of natural hazards. There's no difference between that for this case. And for socioeconomics, the population will be the most important one. But during COVID-19, the mobility of the human being will be the main factor, right? No mobility during COVID. So what do you say? What would you say then? What would be the?
I mean, I wanted to know how do you think which of these factors that you listed here changed the most between those 2 periods, before the pandemic and after the pandemic? Which of these factors, because some of them had to have different values so that the outcome was different. So I mean, like which of these factors changed the most between those 2 study periods?
Yeah, supposedly it should be mobility.
So staying at home is making the map green.
Yes.
Yeah? Because other factors, they don't really change much. Like you don't have air quality here, right?
No. But during COVID-19, it is true that the patterns will be modified, altered, like a temperature. If no mobility, suppose the temperature will be somehow reduced. Airport, of course, because like the pollution is primarily produced by cars, transportation, and with that, suppose the temperature be increased, so that we may not see the direct parameter that tells us the change, but the inference may become a factor that influence the parameters used in the study.
Yeah, so by comparing the 2 data sets from before and after pandemic, we could like see which of these variables were most different.
Yeah, I see your point. This is English. So it may be interesting to see further how to answer this question more precisely. Because what your question is about something that may not be able to see from the listed parameters directly. So that it will be interesting to investigate further. Though it's not listed here, but somehow what we have found by using the same inferential factors, we obtain a greener Earth. However, that parameter, now the question in mind cannot so obviously be answered by the listed variables. So it should be interesting to further investigate what exactly behind. I think that might be better way. By guessing, if we don't guess it correctly, it would be better to further investigate how, why this would occur.
Okay.
Okay?
Thank you.
Very last question, because we know we have another meeting, or the PhD students have to move to another lesson now.
So
Ask the question, not then ask the question.
Igor, you have a question?
Sure.
Oh, well, I could get some question.
I remember your name.
Igor.
As for the model, apart from like the administrative borders for the index, for the sum index, right? There was some previous slide. What are the other factors that affected the model? So because we there at some map we could see just like these administrative borders, right? In the map. So I'm just asking about other.
You mean a map of vulnerability or Heat Island map? Which map? This map?
It was oh this yeah the environmental. Yeah, so that's why I'm asking what are the other factors just apart from administrative borders that affected like these results.
You see very easy the border between Canada and US, for example.
Yeah, for example.
Oh. Well, and the data we use, there are certain criteria. We have to be able to obtain them. Actually, factors first. The factors that influence the global environmental variability should be a lot. But the data we can obtain will be limited. We need to rely on the global data. So data availability will be one issue we have to consider. And then the data has different types, that belongs to different types. Then the resolution, how the data is corrected, will be different. Right? For example, if you consider population, the whole USA, one population. Canada, one population. Right?
So it's focused on the country.
Yeah. So, but we have like here, we use 16 data, and they have different, they belong different type of data collected. So
the
that would be
smallest unit on the map was a country.
yeah.
Country.
Depends.
No,
Yeah. Depends on what type. Is it like a soil moisture, temperature?
now speaking about population.
Population will be the same, right?
Okay. No more question? If not, I would say thank you for the questions for your side and